webinar this week on coffee and wings, and thanks for all the great work that you do. It's a privilege to be with you.
You're very
Um,
welcome. Thanks for joining us. And your presentation looks at good and you sound good as well.
well, today we're gonna spend some time talking about stabilized approaches and what can be done to achieve a stabilized approach using a guided visual. I am joined by my colleague Sabrina Micklejohn, and she is a sales manager at Garmin and a passionate aviator. And I know this from working with her. She is all about flying, and she's got a lot of experience. She has flown all over the world in a wide variety of different aircraft. She's worked on developmental projects involving aerospace, EFBs, and she is a very new, proud owner of a VTEL Bonanza, if she wants to tell us maybe a little bit about that. Thank you so much, Sabrina, for working with us today and being part of this presentation.
Absolutely. It's a pleasure to be here chatting with you all today. I'm just a girl who loves aviation, so I'm happy I get to share that with you all.
Also with us today is Bob Abbott. He is a TERPS engineer at Hughes Aerospace and has been at it for a very long time. I think that slide says almost 50 years. He's an air traffic controller as well as being a TERPS engineer with experience designing instrument flight procedures all over the world. He is also a veteran of the U.S. Air Force and has been at Hughes for quite some time. And he is leading our effort in developing guided visuals and working with our partners at Garmin.
Well, thank you, Chris. I appreciate that. To tag on to what Sabrina said, I'm just a guy that loves aviation. So there we go. There we go. So let me introduce Chris to everybody. Chris is the CEO of Hughes Aerospace Corporation and has been truly a pioneer in satellite performance-based navigation from pretty much the onset. He's the industry co-chair for the U.S. Helicopter Safety Team. Uh, he's on the board of directors for Vertical Aviation International, formerly known as Helicopters Aviation International. He's dual rated. He's an ATP, airline transport pilot with type ratings in the airlines, in business, and the proud owner of a Robinson 66. He's FAA CFI double I and dispatcher and instrument flight inspection and procedure evaluation pilot. What that means is he gets to provide me with all of the data needed to design a flight procedure. And he's also a military pilot and veteran. He's got a great story there. Uh, his helicopter background includes flying the longest helicopter oceanic uh, rescue mission in history, and that's a fabulous story to listen to read about. And he's recognized as a fellow of the Royal Aeronautical Society and holds a bachelor's of science from Embry-Riddle University and a master's in business administration from Brown University and the International Business School in Madrid. So he's currently flying his TBM 850, the Robinson 66. He flies UASs everywhere we need airport evaluation, and his latest qualification is the 787 Dreamliner. He's having a lot of fun.
Thanks, Bob. I was going to say I slept in a Holiday Inn Express last night too, but actually I slept in a 787.
There you go.
Hey, let's talk about stabilized approaches and guided visuals. You know, the FAA looks at this. The airlines have certainly looked at FOQA data. And until we had FOQA data, we didn't know how bad of a job we did at stabilizing an approach landing on a runway. And once we saw the data, wow, it really stood out. And what we learned is if the aircraft is not stabilized on its approach, where the airspeed is too high or too fast, too slow, you're high and fast, you're trying to force it onto the runway, or you're not and you land short, there's a high probability of having an accident. These are just some accidents that could be attributed to unstabilized approaches. But just in GA, from 2016 to 2022, there were almost 1,700 wrong surface landings involving general aviation. So not only is a stabilized approach good for landing on the intended runway, but those wrong surface landings, that means that those were pilots that landed on either the wrong runway, a taxiway, or the wrong airport. So what is an unstabilized approach? It's when the aircraft, the speed is either too fast, too slow, the aircraft is too high, lined up on the wrong surface. You have all these deviations that can create hard landings, long landings, runway excursions where you depart the runway either because you go off the end of the runway or you're unstabilized when you touch down and the aircraft departs laterally off the runway. FMS guidance can eliminate this almost entirely. And that's what FOQA data has shown, that if you have guidance that can be used from the avionics, you can have a three-dimensional path to the runway. So that's what a guided visual is. So the guided visual is where we design an approach. It's in your FMS, you have a chart, and you use it in visual conditions to align yourself with the runway laterally and vertically. And it enables you, if you couple it up with an autopilot, to be heads up and outside the aircraft, looking for other traffic, for obstacles, for an undesired aircraft state before you get into it so you can correct for it. So it reduces the pilot workload. And oftentimes controllers will clear a pilot for a visual approach. But if it's not where you're lined up with the runway, let's say it's trajectory based, meaning there's some curves involved here, well, that can create all kinds of stress and workload for the pilot. So a long time ago, I worked with the FAA and was the architect of this notice 8900.28, which came out in 2008. And the idea at the time was if we could use the FMS to create stabilized approaches and use it in visual conditions. So we had runway 29 in Newark, but it didn't have an instrument approach because it went into LaGuardia and Kennedy's airspace. So the typical approach when they landed on 29 was to come off on the ILS to 22 left, break it off, and then you would circle to runway 29. This is radar PDAR's track data, and each one of these squiggly lines represents a number of aircraft over a short period of time that were maneuvering. And you can see each one of these aircraft maneuvered differently. Pilots all turned at different places. So some people were too close to the runway, some people were too high, some people overshot. So there was a lot of FOQA data that said, wow, this runway sees some pretty interesting approaches. So what we did is we created a notice working together, and this was the birth of FMS visual guidance, and it kind of took off from there. And this was back in 2008. And everybody was concerned like how this was going to work, but it works really well. So Hughes, we recently were featured in an article that AOPA was in the April edition called How It's Made. And this is a great little article if you're interested in how we develop these procedures. And this is an article about a specific procedures that we built up in Anchorage at Merrill Field, which is the busiest GA airport in Alaska. And by the way, if you're going to go to the NASAO conference this month in September, please stop by and say hello to us. We'll be We'll have a booth there. And if you'd like to talk about flying, then you're based up in Alaska. So how do we do this? So the FAA has given us all different types of authority to act on their behalf to go out. And in this case, we're going to evaluate obstacles that are off the airport, off the heliport. And we go in, we evaluate its height, its location, and then we can update the database so it's more accurate. If you don't, well, this is how the FAA treats obstacles. And it's a phenomenal system in that all of the obstacles in the United States are in a repository online, and they're rated from 1A to 9I. 1A is the highest category, meaning that it's 20 foot on the horizontal and 10 feet on the vertical, that they think it's that accurate. When you get to a 9I, look how much airspace you're going to block out because they're not sure where the obstacle is. So if you want to put a waypoint there and navigate, you can't. You'd have to dive over this because it's protecting the airspace. So what we would do is go boots on the ground and evaluate and do a ground obstacle assessment of that. And then if it's not there anymore, we'll update the database and say it's been removed, or we'll get its actual accuracy and we can bring it into a 1B or 2C conformity. Another thing we'll do is we'll pull all of the authoritative sources that are involved at an airport or a heliport and examine that. It's all imported with the data that we collect out in the field. And then TERP's engineer like Bob is going to import all this into software and then develop the procedure, and it gets coded. And then we work with our partners in Garmin who put it into a database. We can also in software run simulations like this one here, where we're evaluating the performance of a procedure, where we can put in temperature, winds, and other conditions. And then we'll go out and we'll do a flight inspection in our own aircraft of the procedure, or we could do we also do simulate our evaluation of lighting, like visual lighting surfaces such as VGSIs and airfield lighting, and how they interact with the approach. So some quick terminology: PBN, performance-based navigation. Even though you're flying this visually, it's still PBN. We're using differential GPS, in this case WAS, to give us sub-meter accuracy. Raw GPS is accurate to at about 20 meters. If you can augment the signal, you can correct it and bring it down to 1 to 2 meters of accuracy, and that's what you're getting with WAS. The guided visual, it's going to give you a day-night VFR clean surface to navigate to the runway. Required RNP, well, there is an RNP involved, but you're not required to have an RNP certification to fly a guided visual. It's very easy to do. It's going to give you that lateral and vertical guidance and a three-dimensional path to the touchdown zone. These guided visuals that we developed with Garmin have radius to fix or RF segments in them. So we'll talk about that. Sabrina will in her portion of the presentation about what they are and how you can find out if you've got it or not. So here's an example of Grand Prairie Airport, just south of DFW. You know, if you look, there's just a bunch of runways here, and they're all kind of oriented in the same way. And it's not easy to pick this airport out. If you fly and you go there even IFR, there's no approach to runway 18 because you've got the Class B surface area right here. So the only instrument approach is to 36. But as luck would have it in Texas, we always land to the southeast or the south most of the time because of the winds. So you'll wind up flying out, and they'll put you on a downwind, and they'll say airport 1 to 2 o'clock and 7 miles. Well, it's not easy to see where that is and figure out where you want to manage your energy, basically to execute a 180-degree turn. So that's what the guided visual does. So once you're cleared for the visual, you can pull up the guided visual and execute it, and then use the automation to your benefit to help you have a stabilized approach. Some things to know, though. ATC does not have a copy of guided visuals. ATC is clearing you for a visual approach, and how you maneuver the aircraft is up to you. So you can't request a guided visual approach. They're not for use in IMC conditions. it does have RF segments, so you need to be familiar with RF and if your airplane can fly them. And one pointer here about RFs is this would be a radius to fixed turn. You can't fly direct to the first waypoint in an RF segment. You would have to join it at least one segment prior. So you have, and I'll use the terminology here, the entry point must be tangent to the RF arc. So it's preceded by a track to fixed leg or TF leg. You can get these charts for free in the Hughes app, which is also free. You can scan this QR code and you can sign up for the app and you can get free charts, free weather cameras, and a bunch of other safety tools. And you'll notice when you have it that there's a Garmin tab and you can tap on that in the app and you can download the guided visual charts and have them in the app. If you don't have a subscription for the guided visuals in your database, there's a tab you can click on right here that'll take you where you can purchase it and you can have all of that data. So I'm going to turn this over to my colleague Sabrina, who can talk about some real world scenarios.
Hi, everyone. I think Chris did a great job of setting us up and explaining the design process behind guided visuals, as well as some of those benefits of when we could use that. So for today, coming from the Garmin side of things, we wanted to talk a little bit about the operational side of how we use guided visuals with some of those avionics we have in our cockpit today. So today we're going to be talking through a scenario of a night flight into Scottsdale, Arizona. If you guys are familiar with this area, it's quite a complex space. You know, we've got a lot of congestion and traffic down in the Phoenix area. We have the McDowell Mountains there off on the northeast side. And runway 21, you know, we've got a lot of business aviation traffic coming into this airport, a lot of training airports or training aircraft into the Scottsdale area. So a lot going on in that environment, especially when you're flying at night, because you've got the bright light city from Phoenix right there, as well as the night or the darker side as you're coming there by the McDowells. So especially if you haven't been into Scottsdale before, it's important to know what to do and find a stabilized way that we can get into these airport environments. So this picture that you see on the right there is just an example of what you might see in your avionics if you have visual approach capabilities. What Garmin has done since 2017 when we first released visual approaches will basically take any airport that is registered, you know, in our database. We can create a visual approach off of that by taking your runway threshold and drawing a 3-degree line basically all the way out a couple miles out so you can join that to come in on a visual. Now that works in places where I live out in Kansas, where there isn't any mountains or big downtown city stuff around me, but that can be difficult in places like Scottsdale or up in the mountains if you've ever flown into Aspen, where we have these tricky environments, whether it's the terrain around you, whether it's tall downtown buildings, or if it's the light saturation. Let's say you're flying into LA at night. Sometimes it can be hard to really identify where that airport environment is around you. So there's times that we want to have a more stabilized way to get into the airport environment, and that's really the idea here behind the guided visuals. So as you can see here, potentially using this visual approach is going to put you right over the McDowells. So you're going to have to come in a little bit high and create an unstabilized descent to get down to runway 21. So if we go to the next slide, we'll see what our friend Shannon actually did using Garmin's guided visuals. So the normal way of flying, he usually comes over the McDowells and has a more abrupt loss of altitude and speed at the same time. At night, the guided visual was much safer as it avoided the McDowells completely. He said it was a great learning experience for him because it felt like the turns, there was a little bit more turns to get towards the final, but it made it a much safer for clearance of obstacles. So he's one of those big advocates for guided visuals and really thinks that this is going to be a game changer into some of those difficult airport environments that we see. And that was from our friend Shannon in a citation M2. And if we go to the next slide, we can actually see what that looked like when he executed the flight. So right there on the left side, you'll see this little dashed yellow line. That's what you would normally see with a visual approach. So that's your typical one you'd see in your avionics today. If you see over on the left side of that, that's what the guided visual looks like. So it takes you all the way around the side of the mountains and allows you to have a continuous descent towards the runway. So that's giving you time to get configured, get set up, and it really helps you have a little bit more situational awareness coming into these complex environments. And this here was using FlyStow, which is something that we do integrate now with Garmin. So you can actually look at some of your previous flights and go through and analyze all those details, which is pretty cool. So this is what it would look like coming in on that guided visual. This is right as he's coming by the McDowells, and we're about to turn right towards the runway into Scottsdale. So as you can see, these approaches are now fully autopilot coupled. So with your synthetic vision, you get a really good picture of what that's going to look like. I'm on my autopilot. You can see we're at a much lower altitude. We're at 3,200 feet because we're able to come in front of those mountains. So a little bit more stabilized coming in. And then on the right side, you'll see a picture of what these procedure plates would look like. So if you've seen an instrument procedure, it's kind of similar in that sense, where if there's any sort of speed restrictions or altitude restrictions, we'll put those in there for you. These are fully geo-referenced, so you can see them in your panel as well as on the Hughes app if you're using your mobile devices. So a lot of great tools here to help increase your situational awareness and help you butter those landings into your airports.
Sabrina, what do you think? Maybe do a polling question?
Absolutely, let's do it.
Actually, panelists, you've answered all of the polling questions. You've already answered what they're all about.
Okay, well, I guess we can just keep going on then.
Yeah, keep going. You already answered them. I've been keeping track of it. I'm like, oh, there's the answer to that one. Oh, there's the answer to that one. So,
We can see who is paying attention.
oh, is that what you want to do? Okay. Well, we can do one if you want to.
Just
What, Chris?
go ahead. I'm sorry.
Can I use the autopilot when flying a guided approach? Yes, no, or not sure. So we'll let those questions come rolling in. And just a real quick one, are these approaches available for the G3X? In terms of a question from the audience.
So that's going to depend. We'll talk a little bit about it towards the end and compatibility. It really depends what kind of aircraft that's in, as well as the capabilities of the units itself. So we'll talk about that in a little bit.
All right, great. And I'm going to end this poll in 5, 4, 3, 2, 1. And I'm going to share the results with everyone. 91% of us are good listeners and said yes. 3% said no, and 6% said not sure.
Yeah, that's how I wound up in the Army, Laura. I answered not sure.
Ah, gotcha.
All right, I will.
Okay, we'll continue on here. So basically with our scenario, we've decided, we really liked what we saw that Shannon was doing on his approach. So we want to get ourselves set up to do a guided visual. So this next process is really just talking you through what you need to do to create an account here at Garmin with us and get those going for your avionics. So the first thing I just want to preface with, if you're already a customer with us here at Garmin and you have an existing one-pack database subscription, the best thing you can do is contact us either on our phone number or through our email, and we can actually help you switch over your current one-pack to a guided visual one-pack if you're doing that with us today. Now, if you're brand new to the Garmin ecosystem, on the next slide here, we're going to kind of walk through what you need to do to get set up with us. So the first thing you'll want to do is create an account. We'll start on flygarmin.com. In the top right there, you'll see a little sign in button. And once you hit that, there'll be an option to create an account. So we'll go ahead and click that button. And then that will take you into your new account. Up here on the top right is where you're going to see any aircraft associated with your account. So you can go ahead and click My Aircraft. And then in here is where you can put in those profiles, and every single new aircraft that you have, you can put them all right in here. So if I click on the Add Aircraft button, this is where you're going to put in your tail number, your serial number, what kind of avionics you have, and the big thing you'll want to find out is your system ID. Now, this is something I highly recommend when you get into your avionics, take a picture of that when you see your system ID. We use it all the time, so it's a good tip for us to use, especially if you need some help from us here at Garmin. It allows us to identify your systems a little bit easier. So as you're going in, you'll put in your aircraft details and that system ID, and then that will take you to your full aircraft profile, which we'll see on the next slide. So now we see we have our aircraft in here. The next step, since we've created our aircraft, is now attaching databases to that aircraft. So you'll go down to the bottom right and click the Buy Databases button. And in here, this is where you'll walk through all the different options that you have for databases for your aircraft. Under step 3 here, you'll see there's multiple tabs across the top. The furthest one on the left is that recommendation section. This is really where we take into account, what region you're flying in, what kind of avionics you're using, and we'll see what's most beneficial for you. So it's a really good logic system that we have to help you find the best databases for your operations. So as you can see, for the suggested ones down here, we have the United States Guided Visual One Pack with flight charts and an America's Guided Visual One Pack with flight charts. So it really depends where you're flying. For me personally, I would just use the United States unless I'm, going to visit some family back home. And just so you know, we also have an option for a one pack without the flight charts if you would prefer to not have those on your avionics. So those are a few options here for selecting. So basically, you'll just add that to the cart, go through the purchase process, and then they will be tied to your airplane. But now there's one next step that we need to do to get that into your actual avionics. So let's take a look at that. So the next part is actually downloading the data. Now, I'm sure many of you are familiar with this process, but in case we have any new folks here, just wanted to briefly explain the options you have for downloading data with Garmin. The first one is going to be through the Garmin Aviation Database Manager. And that one we have an option for, both your MacBooks or if you're using Windows, we have an application that you can download onto your computer. It's really easy to open up, and once you do in here, you'll just sign into that account that we created just a few minutes ago. And in here, you will see all of the different databases associated with that aircraft. So it's a really seamless process. You stick your SD card in, and it walks you through all the steps that you need to do to get that downloaded. The next option is our Garmin Pilot Database Concierge with a FlightStream 510. So for any of you that have purchased a FlightStream 510, that allows you to take your databases from your Garmin Pilot and push that up to your avionics via Wi-Fi. So that's another option available to you if you have that. And the third one I just want to mention, it's called our GDL60 or a Garmin Data Link. It's basically our data link solution that we have with PlaneSync technology. It's a physical hardware that's installed into your aircraft and it's attached to your battery. So it'll basically wake up in the middle of the night for a brief few minutes just to check to see if there's any database updates, and it will automatically download those for you. So the next time you turn on your aircraft and your avionics, it'll push that update into the panel. So really cool. We've got multiple options for getting that data and getting those guided visuals onto your avionics. So now that we've gone through, we've created our account, we bought our databases, and we've installed our databases, let's go through and actually do the scenario flight into Scottsdale. Now, this example we have here is a G1000 NXI for a Cirrus, so that might look a little bit different depending on what kind of airplane you're flying, but we really just wanted to walk you through the flow. The first part of that is going to be going into your procedure selection area. So in your avionics, how you would normally insert like an RNAV approach or an ILS, you're going to go right into that same space, and that's where you're going to select the approach. So once we hit that button, then it'll take us to our next slide here, which will show us all the approach options available. So that first one there highlighted in blue says RNAV GPS G21. That G is what we use to designate a guided visual approach. So that's going to populate as an RNAV, but it is a guided visual. So in here, we'll go ahead and select that guided visual approach. And the next step is going to be selecting that transition. Now, if you've ever flown into the Phoenix area, you'll know we have YOLO is one of the last terminating fixes on one of our arrivals into the area. So from that point, you can really jump on our guided visual and flow straight into Scottsdale, which is really convenient. So we'll go ahead and select YOLO as our transition here. And then the next step is going to be setting everything up and hitting that activate button down in the bottom right. Now, I preface that by saying it's probably a little bit different based on what you're flying, but still the same flow. You're going to come in here like any normal approach and activate that or load it like you normally would. So right here on the screen, I really just wanted to show you all the different ways that we can now view this data that we've loaded onto our panel. So up on the top left there, you'll see on our map all of our new waypoints that we have associated with our guided visual. So you'll see we have SDL07, SDL03. Those are all new fixes that Hughes was able to create to help us get into that airport in a more seamless way. And down in the bottom right below that, you'll see in some of our aircraft, we have the option for a profile view. So you can see any of your altitude restrictions there, as well as all of those fixes to really help increase that situational awareness. And then on the right side, you can also see those restrictions as well if you have the active flight plan page open. So now let's say we have the ability to put charts on our panel. How are we going to go about and do that? So where you would normally add, your airport diagrams, or if you're doing an approach, how you would normally pull those up, you would go through that same flow again. And under that chart section, you will see the RNAV G for runway 21. So this first page here is going to show you the actual approach, and that's going to be fully geo-referenced. So as you're coming in, you'll know exactly where you are in relation to that runway. And then I also just want to note that there is a page 2 for every guided visuals. That second page really just gives you some good feedback and information about executing that approach. That's good to know as a pilot. So I highly recommend checking out that page 2 that has some good tidbits of knowledge for you. And then this is just another example showing, we can have our charts, we can have our map and our profile view, depending on your avionics, but there's a lot of different ways that you can set up these guided visuals to really give you that information that you need to execute these approaches. And then here's just an example of what that's looking like as we're coming in front of the McDowells again. We're about to make that right turn into the airport itself. So we're definitely at a lower altitude. We're a lot more stabilized. And I really like that with guided visuals, we now have a chart associated with that too. So it's a really good tool to use in a cockpit if you're briefing just yourself or briefing other folks with you. So it gets you forward thinking and how you're going to come into that airport. Visuals are something that are really great when we can get them from ATC, but sometimes they kind of leave us with more planning that we have to take on as pilots. So these guided visuals are a great way to give us more tools in our toolbox and help us get into these airports.
I think it's absolutely huge that the chart is now available in the avionics, just like any other chart that you would get in the chart pack.
Absolutely. Especially for some of these approaches that might not have, or some of these airports that might not have approach options for me. Like this one specifically in Scottsdale, the only approach they have into 2-1 is an RNP approach. And I can't do that in my aircraft most of the time, or I'm sure many of us are in the same boat there. So having something like this that gives us all of that structure and that detail in the same way, in the same flow that we're used to having, I think that's really huge.
So you've got excellent situational awareness. Sabrina, would it be all right if I went back maybe 2 slides just to talk about the waypoint conventions? Because it might be new for
Absolutely.
some folks. So you'll notice here, you're familiar with yellow. So if there's a waypoint that ATC commonly would use in sequencing and it makes sense, we would include that in the design. But when we create the procedure, we create waypoints that are not part of the National Airspace System. These are unique to the design of the guided visual. And the architecture of it is we'll use the first 3 letters of the airport it's associated with, in this case, SDL for Scottsdale, and then we'll use 2 trailing numbers that'll sequentially follow the approach. So that's why you see SDL 087 all the way down to the final approach fix, if you will, SDL 01, and then the runway. Now, again, if you told the controller you were going to SDL 07, they would have no idea what you were talking about because they cleared you for the visual. So know that these waypoints are available and you can see them graphically in many different ways in the avionics and with the charting, but it's unique to this guided visual approach.
Okay, I think we're good to go to the next one here. So this is really just giving you a list of where we have guided visuals available today. The team wanted to get these out to you as soon as we could. So right now we have 31 guided visual approaches at 25 airports in the United States, with our goal to keep expanding based on our feedback from you all. So if you fly into some of these complex environments, I'm sure you have a few that you remember those approaches, long after you've done them because they challenged you a little bit. So if you have any feedback like that, we'd love to hear about some of these airports, maybe, what you're flying, what those situations are like, so we can continue to add this and increase safety for pilots across the globe.
And we're going to be adding a guided visual departure as well. So something you can look forward to not only help with landing at a runway, but when you're departing, to make it easier for you to fly the aircraft.
Absolutely. So this next one is really where we wanted to talk a little bit about radius to fixed legs. RF legs are becoming more popular in our modern airspace or terminal procedure design because of the increased accuracy and predictability that we get with making those. Now, on a typical, let's say you're making a typical turn from one fix to the next, usually you're going to have some sort of a standard bank rate that you're using. But with an RF leg, what it allows us to use is a center point, and then our GPS will actually help manipulate that bank angle to keep us at a constant radius on that leg so they know exactly where our aircraft is going to be. So that's really how we can get into some of these more difficult airports in those tighter turns because we can have speed restrictions. Our GPS knows exactly what sort of bank angle to use to help us execute those procedures better. So RF legs have a lot of benefits, and that is something that we're really going to start seeing in our procedure designs in the future. And this one down here in the bottom right is just an example of what that RF leg would look like on the Aspen guided visual.
So it's a very high performance code. So if you look at ARINC 424 coding, that's the binary language that all these procedures are made from. And Bob, I will pick your brain for a second. How many ARINC codes are there? Is it 30, 35, 34? It's never an even number.
How many airing codes are there? To be honest with you, Chris, I don't know.
I know I'd
I
put you on the
just I
spot.
just know what they're based on.
Yeah. I want to say it's like 32 or 37. It's a goofy number. Now, not all of them are commonly used. The most common track fixes that you see are the TF legs. And a TF leg is what you see between ASC 01 and ASC 02. And that is a track to fix. That's what that stands for. You also have flyby and flyover waypoints. And when we design procedures and then work with Garmin and the coding of the procedures, that binary code goes into a database that you subscribe to in the aircraft. And when you pull up the procedure, it's all ones and zeros, talking from the avionics to the autopilot to the flight director to manipulate the aircraft. So the aircraft's getting signals in GPS and WASP for its accuracy, and it's looking at this binary code that's telling it what to do. And we create different coding architectures like fast data blocks, CRC code that go into the architecture and design of this that causes the aircraft to perform well. So even if you're not in IFR conditions, this technology can be used to help you figure out if you were on this turn and it's a really windy day. Let's say you've got a stiff 30 knot crosswind. The RF leg doesn't care, and the avionics don't care because they're going to work hard for you. And whether you flew one aircraft or 1,000 aircraft over this RF leg, every one would look the same. You wouldn't have all of those squiggly lines like you saw in the earlier slide. You would have one railroad track of performance, and the aircraft's going to fly flawlessly, which is really going to help you out so you don't overshoot, undershoot, or get too low or wind up too high.
So the next part of this is figuring out our avionics and how or whether we can do RF legs in them. So the first part is on the avionics side. So can my hardware physically execute an RF leg? Now that depends what you have. So these are just a list of some of the examples of avionics that are technically compatible, but that is just the first step in the process. So typically if you have, a GPS 175 or anything of that nature, or a GTN series, there's also going to be an attached AFMS or documentation around that. So while you might physically be able to do that on the unit, it's up to the avionics and the manufacturing side and how they certified that aircraft to determine if you can execute them. So if you're using, those GTNs or GPS, you'll want to double check in your AFMS. There's a section in there that you can search for RF, and it'll show up with any RF legs and whether you can or cannot execute those. Now, if you're flying in an integrated flight deck, so whether you're a G1000, G3000, G5000, you'll want to look in your AFM or POH from your manufacturer in the limitation section, and that's really where it's going to outline the navigational operational capabilities that you have for that system. So another way you can do that Chris was talking to us about is you can go into your avionics on your next flight. You can actually double check to see if RF legs are capable on your aircraft. So you can type in, the CRQ airport, try to pull up that RNAV GPS X-ray, and there's actually an RF leg attached to that approach that is a non-RNP approach. So there's only a few of them in the US, but this is a quick and easy way to tell if you can do that with your avionics. Now, the reason I wanted to preface this whole thing and, double checking to make sure that you can have these is if you go out and you purchase the Guided Visuals database, go through the process of getting it downloaded onto your avionics. If they're not RF leg capable, when you go into the approaches section where you would go to load the procedure, it's not going to populate there. So it's really good to take this extra step and double check to make sure that you are compatible before going through and downloading all that to your aircraft.
That earlier question, Sabrina, on the equipage.
Yeah, so I think the question earlier was on G3X, and that one is going to depend. I don't know off the top of my head specifically for G3X, so we'll have to double check to see if they are RF leg capable and then if they are supported for that specific manufacturer. So if you had that question, feel free to send us an email and we can walk through the steps together and help you find out. And then one thing we wanted to put in here for the guided visuals, just a disclosure for everybody. I know Chris had mentioned it earlier, but ATC does not have knowledge of these procedures. They really are there to help us build that situational awareness. You still have to comply with everything that ATC says to us and maintain that visual contact with the runway. If you want any additional details or you want to see that list of all the airports that we support for guided visuals, you can head over to garmin.com/guided visuals. And we definitely encourage you to check out page 2 of those approach plates that we talked about earlier that has some of this good information on there as well. And then, like we said earlier, we are really interested in getting your feedback and hearing about your experiences with guided visuals, or if you know of any additional airports that you'd like to see added to the database. So if you think of any, please send us an email over to aviation.sales@garmin.com, and we'll be happy to take a look at those and share them with Chris and his team.
So this QR code will take you to the Garmin portal that Sabrina described. And she has very foolishly asked me to put her email address up here. So if you have questions, you can reach out to her directly. And of course, you can always reach us at info@hughesaerospace.com.
We love to hear your feedback. That being said, 1,000 emails might be a little bit much to have this time of day, but any feedback or things we can do to help you understand maybe RF legs, or if you can use